I'll start with an easy example here. You have your actual reading, say something's 10 miles long, distance A is 10 miles long, distance B is 100 miles long. But then you measure it, and your measurement for this one will actually be, say, 9 miles, or it could be 11 miles. Either way, you're off by 1 mile. And that absolute error will be the same for the 100 miles. You're supposed to measure off 100 miles, but instead you get 99, or you could get 101. Either way, you're off by 1 mile. Your absolute error is 1 mile. So you can describe this two different ways. One way is you take the amount that you're off, which in this case is 1 mile, or you could say it's your actual minus your measured, which will still give you 1 mile. Then you divide that by your actual number, which is the 10 right here. That gives you 0.1, which gives you a 10% error. Notice here also, I forgot to write that, so I'm going to write this here. I wrote kind of small here, but that's actually 1 mile divided by 10 miles, so the miles will cancel, and it'll just be 0.1, which is no units, which means you move your decimal point over 2 places, and that gives you a 10% error. I also did a video on showing the logic on why you move your decimal point back and forth to figure percentages, so you can see that if you want to. Then we can also take distance B here, which is 100 miles. We take how much we're off, which is 1 mile, by 100. That gives us 0.01. Move the decimal point over. That means we have a 1% error. So these are our relative errors, 10% here and 1% here, because it's relative to the total amount. Then the absolute error is 1 mile. And the absolute error will have a unit of mile, because that's how much we're off. But then when you do relative error, it's mile divided by mile, so they cancel.